Hello, my name is Chris Reed. I'm a tutor for Wyzant, and I'm going to attempt to answer the question to this oil problem, tank. First of all, I start out with a circle, which is the cross-section of the tank, and I just draw this, make it a sketch, and then I draw this, kind of, and I make the center of the circle being, 0R. And the equation of that circle, cross-sectional area of the, would be x squared plus y minus r quantity squared is equal to big R squared. And you draw a little section. This is the volume. The key is we want to get this, when we get a volume being a function of h, where h is the height of the tank right here. And the accurate markings on this dipstick stick that's here is going to be v of h as to pi r squared big H. That's the height of the cylinder laying on its side. And first of all, in calculus, we start with a little slab. What's the volume of each of these little slabs going across the tank doing this? And you could start with the volume of that. The length of this slab is, would be, so you start with, dV equals to big H times 2x, and then delta y is your right here. And of course, now you could rewrite this equation, going from this equation to the circle being a function of y. So now we can say volume is the integral from 0 to h, we'll say being a function of h, and that will be big H. You get 2h times, and then you got square root of big R squared minus y minus r quantity squared dy. Okay, I don't have a whole lot of time to do this calculation, but it turns out the antiderivative of this becomes it's actually a new equation. Let's go to the next page. And it turns out it is a long formula, so we'll say volume of being a function of h does equal this. That would be pi, over 2 plus the inverse sine of h minus big R over R, and then plus h minus r times the square root of big R squared minus, and then you get h minus big R quantity squared. This whole thing is over R squared. Okay, and of course this is times your big H R squared. Okay, so if we were to take the ratio, because the idea is we want to figure out the percentage being a function of H and where we mark the H on the tank. So V being a function of H as to pi big R squared H, which is the full volume. The HR squares would cancel out, and the pi's would cancel out. And the first part, this actually would equal to, this is what you're doing, you're normalizing the curve, plus the inverse sine of h minus r over r, and then plus, now you get h minus r times the square root of r squared minus h minus r quantity squared, and that's over big R squared. Yeah, the HRs will cancel out, and actually these would each be divided by pi, because that's, and this would be pi right here. So if we plug in our numbers, the radius happens to be 5, because the diameter of the tank is 10. So we could rewrite this ratio as 1/2 plus inverse, and then you got h minus 5 over 5 plus h minus 5 times the square root of r 25 minus h minus 5 quantity squared over pi over 25 pi. Okay, so it looks like we're out of time, and this is what you do. You graph this, and you could figure out the markings in relation to h and r. So hope this helps, and have a good day.